5.2 in Algebra 2 is graphing simple rational functions such as y equals a constant over x. When you have y equals 1 over x, 2 over x, 5 over x, or 10 over x, they pretty much all look the same. If the degree of the denominator is bigger than the degree of the numerator, in other words, if the power on bottom is bigger than the power on top, it has a horizontal asymptote at 0. And that's going to be the case with these rational functions. The power on bottom will be bigger than the power on top, and that creates a horizontal asymptote. It's difficult to teach horizontal asymptotes in algebra because we haven't taught you limits yet. Technically, a horizontal asymptote is found by doing the limit of your function as x approaches infinity. Well, my function was 1 over x, so give me a number close to infinity. Well, how about 10? That's a big number. That'd be 0.1. How about 100? That's a bigger number. How about 1,000? That's bigger. That's closer to infinity. As the denominator gets bigger, please notice the value gets smaller, approaching 0. That's why you have a horizontal asymptote at 0. Now, let's erase this. And you're not ready for limits yet. I'm just telling you how they do it. If the power on bottom is bigger, the horizontal asymptote is at 0. Whatever value makes the bottom 0 is a vertical asymptote. So this has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Now if you put in a 1, 1 over 1 is 1, so it goes through 1, 1. If you put in a 2, 1 over 2 is 1/2. If you put in a 1/2, a lot of people don't know this, 1 divided by 1/2 is 2. So I graph these, and it has to curve towards these asymptotes. If you put in a -1, you'd get out a -1, which tells me again it has to curve from asymptote towards this other asymptote. So this graph of y equals 1 over x is extremely important to learn because we're going to use this to shift. So once you learn what that looks like, we're going to modify it ever so slightly. Now we're going to modify it a little bit. Instead of just 1 over x, it might be in this form. Once you get used to this, you're going to know that, let's see, a vertical would be x equals a is going to be your vertical asymptote, and y equals b is going to be your horizontal asymptote. So for example, y equals 1 over x minus 3 plus 2. Well, what is the a? Here's the way I usually do it. What makes the denominator 0? Anything that makes the denominator 0 and does not cancel creates a vertical asymptote. Did I say that you had a vertical asymptote at x equals a, in this case 3? I think that's what I'm stating up here. You have a horizontal asymptote at usually whatever this last number is at the end. So your horizontal asymptote is going to be y equals 2. So I make an asymptote at y equals 2. Then all you have to do is determine, now listen real fast, it cannot be up here and down here and still be a function because it would fail the vertical line test. All you need to do is determine whether it's top or bottom of the horizontal asymptote. If I put in a 4, I think I get out a 3. So 4, 3 is above the line y equals 2, so it has to curve from asymptote towards asymptote. And if you put in a 2, 2 minus 3 is negative 1, plus 2 is 1, so it's going to go through 2, 1, and also go curve from asymptote to asymptote. So what I usually ask on these graphs is I need you to be able to identify the vertical asymptote, the horizontal asymptote, which is y equals 2, and a minimum of 2 points. And I'll be happy with a graph of this. This, by the way, is called a hyperbola, a rectangular hyperbola. So our assignment in 5.2 is going to be 3 to 29 odds. That'll get us some graphs with rational functions, including some horizontal asymptotes that we have to figure out ourselves. Okay, we're going to start in and work through some of these problems. 3 to 29 odds. 3 is 3 over x. You can always make an xy table. Again, what value makes the bottom 0? Well, that is a vertical asymptote. So there's a vertical asymptote at x equals 0. What number is added at the end here? 0. So again, I usually say if the degree of the bottom is bigger than the degree of the top, the horizontal asymptote will be at 0. So I have my vertical asymptote labeled, I have my horizontal asymptote labeled. Now I'm going to mark off a few in each direction, just so I can graph. So I have 3 over x. If you put in a negative 1, you'd get out 3 over negative 1 is negative 3. So I have negative 1, negative 3. I need to put 1 on either side of the vertical asymptote. So if I put in a 1, 3 over 1 is 3. So 1, 3 is up here. Now if it's up here and I have these asymptotes, it kind of has to curve from one asymptote towards the other. Same thing down here. It has to curve from one asymptote towards the other asymptote. Now, what did I say I would require on the graphs of these? The label of the horizontal and vertical asymptote and a minimum of 2 points, one on each side of the vertical asymptote. So hopefully I've given everything required in problem 3. Problem 5 is similar, but it's going to be flipped over because of the negative 5. So I'm counting these a little bit tighter here. If you put in a 1, what's negative 5 over 1? I believe it's negative 5. 1, negative 5. What if you put in a negative 1? Negative 5 over negative 1 is a positive 5. So 3, somewhere up here is negative 1, positive 5. Do you agree that the asymptote is still at 0? Because what makes the bottom 0? That creates a vertical asymptote. So I make a vertical asymptote at x equals 0, which is called the y-axis. And then I make the horizontal asymptote, whatever the thing added at the end is, which is 0. So I have a horizontal asymptote at y equals 0. And I know that it must curve from asymptote to the other asymptote, because this is what hyperbolas do. And this property of asymptotes. They approach it but never reach it. Okay, here's 3 and 5. These are pretty basic rational functions. Now we're getting to ones where they add something at the end. Again, whatever makes the bottom 0 is a vertical asymptote. So this is a vertical asymptote at, what is it, x equals 0, also known as the y-axis. What is your horizontal asymptote? Well, it's whatever number is added at the end. So because this says plus 3, that's going to be your horizontal asymptote. Now, I've been saying if the power on bottom is bigger, the horizontal asymptote is 0. I believe I told you that if the power on bottom is bigger, here's x to the 1 and x to the 0, the horizontal asymptote is 0. But you still have this plus 3. So that's why you have a horizontal asymptote at y equals 3. Choose a value in each region, basically to the left of the horizontal and to the right of the horizontal asymptote. If you were to put in a 1, what would I get out? A 7, which is up here. And it would have to curve from asymptote towards this asymptote. If you put in a negative 1, that's negative 4 plus 3, which is what? Negative 1? So I believe negative 1, negative 1. And again, it would have to curve asymptote towards asymptote. I label my asymptotes. I have point on either side of the asymptote labeled, so I should be good. On 13, what value makes the bottom 0 now? I believe a 1. And that's where your vertical asymptote will be. Vertical asymptote is at x equals 1. Now, how about horizontal asymptote? Is the power of the bottom bigger than the power on top? This is an x to the 1, and a lot of people don't realize it, but there's an x to the 0 up here. Is 1 bigger than 0? You're looking at what's called the degree of the polynomial, the highest power on the variable. So because the degree of the bottom is bigger than the degree of the top, you have a horizontal asymptote at y equals 0. Now we're going to plug in a number on either side of 1, such as 0 and such as 2. 0 is to the left of 1, 2 is to the right of 1. If I put in a 2, 2 minus 6 over 2 minus 1 is 6 over 1, or 6. So that's 2, 6. If you put in a 0, I think you get a negative 6. So 0, negative 6. Put in a 2, it gave you a 6. And again, it's got a curve asymptote to asymptote. And the same thing here. So do I have a point to the left, a point to the right, and both my asymptotes labeled? Okay, we did 13. Let's take a look at 19. 19, what makes the denominator 0? I believe negative 4. Negative 4 makes the bottom 0, so I'm going to make that my vertical asymptote, is at negative 4. Your horizontal asymptote is at whatever the number at the end is. So this one is 3. So you're going to have a horizontal asymptote at y equals 3. Y equals 3. X equals negative 4. And now I have to choose a value on either side of negative 4. What's to the left of negative 4? Negative 5. What's to the right of negative 4 would be negative 3. Let's make an XY table and plug these values in. Now I'm going to put what in first? A negative 5? So what does that give me? Negative 4 over negative 1, which is 4 plus 3. So if I put in a negative 5, I get a 7. Where is negative 5, 7? Well, it's above the asymptote, isn't it? So that means it has to curve from asymptote to asymptote. Choose a value to the right of -4. How about -3? That makes this a 1 on the bottom, which makes it -4 plus 3, or -1. So if I put in a -3, I get a -1 out. And again, it curves from asymptote towards the asymptote. Okay, after 19, we're going to look at 21. What makes the bottom 0 here is 4. So that makes a vertical asymptote at 4. I need to choose to the left and the right. So I may put in a 3 and a 5. Where's the horizontal asymptote? Well, it's at -1 because that's the number at the end here. So you have a horizontal asymptote at -1. Horizontal, -1. Vertical would be at what? X equals 4. Oops. Now, if I was to plug in something, I'm going to put in something like let's put in a 3. This would give me -3 over what? -1. Would that make it 3 minus 1 or 2? I put in a 3 and hopefully I get out a 2. Does that make sense? I hope. Let's take a look. 3 minus 4 is -1. Negative over negative is a positive. That looks good. So where is that going to be? 3, 2 is up here. That should tell you that it's going to curve asymptote towards the asymptote. Put a 5 in. If you were to put in a 5, what would I get out? Well, this would be -3 over 1, so that's -3 minus 1. I think 5 gives me -4. And again, curving asymptote to asymptote. Okay, after 21, let's go look at 27 and maybe 29. These are in slightly different forms, so you really need to listen to what I'm about to say. Whatever value makes the bottom 0 is a vertical asymptote. I think I told you that before. And that's not going to change. So what value makes the bottom 0 is 3. So that means you're going to have a vertical asymptote at x equals 3. Now, how about horizontal asymptotes? Here I need you to learn your rules. I've told you if the power on bottom was bigger, it's 0, right? But here the powers are the same. Do you agree it's 1 and 1? So when the powers are the same, you divide your leading coefficients. 1 over 1 makes the horizontal asymptote y equal 1. So this is going to have a horizontal asymptote at 1. Again, there's two rules. Power on bottom is bigger, the horizontal asymptote 0. If the degrees are the same, like you have it here, you divide your leading coefficients. There's only one other possibility left, right? If the degree on top is bigger. If that's the case, if the power on top is bigger, there is no horizontal asymptote. For all the overachievers out there, if the power on top is exactly 1 more than the power on bottom, you'll have something called a slant asymptote. But I don't believe that's in this section called basic rational functions. Anyway, we have y equals x plus 4 over x minus 3. Let's choose a value to the left of 3 and to the right of 3. If I put in a 2, what do I get? I get 6 over negative 1, so I think 2 gives me a negative 6. Does that make sense? 2 gives me a negative 6, which is way down here. And again, it has to curve asymptote to asymptote. If I put in a 4, now I'm going to make this a 4 and make this a 4. What would that give me? 8 over 1. So I think if I put in a 4, I get out an 8, which is obviously above the horizontal asymptote of 1. And you make your curve from asymptote to asymptote. Now what makes this one different? It's not in this form. Sorry, it's not in this form. You don't have the plus b at the end. They just write it all as a single fraction. So you have to know your rules to get your horizontal asymptotes. Okay, on to number 29. What value makes the bottom 0 on this one? I believe it's a 2, because that would make it into 8 minus 8, right? I'm just marking off some in each direction so that I can make my asymptote. So I know I have a vertical asymptote at 2. How do I know it's at 2? Because that's what makes the denominator 0. So I have a vertical asymptote at 2. Please notice that the degrees are the same. So you have to divide your coefficients. So you're going to have your horizontal asymptote is not at 1, but it's at 1/4. So I have a horizontal asymptote at 1/4. Choose a value to the left of 2 and to the right of 2. So I have x plus 6, 4x minus 8. X plus 6 over 4x minus 8. Let's plug in for x. Something to the left of 2 like a 1. If I put a 1 in, what do you get? 7 over negative 4. So 1 negative 7/4. 1 negative 7/4 curves asymptote to asymptote. What happens if you put in a 3 for the x's? Well, I think you get 9 over, what's 12 minus 8? 4. So if you put in a 1, you get 9/4, which is 2 1/4. So 1 gave me 9/4, and I know it had to curve from asymptote, to asymptote. I apologize, something is wrong here, because what did I just put in? I put the 1 in to get what? This. I put a 3 in to get 9/4, right? So it should be over here, shouldn't it be? 3 9/4 curving from asymptote towards the asymptote. Anyway, these are the graphs of some basic rational functions. I hope these help with your assignment.